Know how to name a compound. Okay, watch this. Here we go. Any name given any formula. The good news is the process is basically the same. Step one, are there metals or polyatomic ions in the formula? This is a little bit easier to check for because you're looking at the symbols themselves. Right away we see Na, and we can identify that clearly as sodium, and we see O, which is oxygen. Sodium is very clearly a metal because it's on the far left of the periodic table, and oxygen is a nonmetal for obvious reasons. Now, if you have a metal and a nonmetal, that is a dead giveaway. You are dealing with an ionic compound, and we only have one of each element. We have sodium and oxygen. So how are their names going to change when we go to name this compound? How are we going to actually write out, it's not sodium oxygen, right? In a binary ionic compound, we can just name the cation and name the anion, in this case, oxide. Notice, oxygen changed its ending to IDE. That is the first section of nomenclature from the Formulas and Nomenclature packet. It's very simple, very straightforward. You take the name from the periodic table and change its ending to IDE. Now, if you wrote OX, if you wrote something like oxide, I'm not going to get upset. I'm going to twitch a little bit, but I'm not going to get upset. If you wrote oxygide, I will probably dry heave a little bit. Now, if you just wrote oxygen IDE, you do not get credit. I'm sorry. What are you doing? Don't just tack it on to the end. You got to change the ending completely. Oxide, please. Plus, it just sounds like it makes sense, right? Oxide? Come on. Okay. And that's it. Sodium oxide. Name the cation, name the anion, done. That's actually going to be the process for most of this. Name the cation, name the anion, you're done. It's very easy. Covalent molecules are different, but they're also pretty straightforward. And let's see what we got here. C and O. Capital C, capital O. That means we have two different elements here. We have carbon and we have oxygen. This is not cobalt. Cobalt is capital C, lowercase o. And that is just one element by itself. But since we have two capital letters here, we are dealing with two elements, carbon and oxygen. They're both nonmetals. So nothing about this says it's an ionic compound. This is absolutely a covalent molecule. How are we going to name it? Well, with covalent molecules, we have those numerical prefixes to tell us how many of each atom we're dealing with. In this case, we have one carbon and one oxygen. Happily enough, the prefix for one is mono. But when do we use the mono prefix? There are rules with this, right? In the case of CO, I am not going to name the first element monocarbon. I'm just going to call it carbon. All right? You do not use the mono prefix for the first element. If it was 2, like in the previous video, we had dinitrogen, we do use a numerical prefix if the number is 2 or more, but never if it's just 1. For the second element, though, mono is fair game. So monoxide. And yes, for a covalent molecule, we change the ending only for the second element, not for the first. So it's carbon monoxide, not carbon monoxygen. And if you ever need help thinking about when to use mono, think about carbon dioxide, right? You've heard that term since you were in middle school or earlier. Carbon dioxide. Well, no one's ever said monocarbon dioxide, and if they did, they were gravely mistaken, and they thought they were sounding smart, but they just sounded like a fool. Carbon monoxide, just like carbon dioxide, we don't use the mono prefix for the first element. We also don't change its name at all. It's just the name of the element. All right, moving on. Carbon monoxide. Next up, we have Na2SO4. So, what do we have here? Well, that looks to me like a sodium ion. Great, because we have a metal, and then we have multiple elements over here. So it looks like we're dealing with a polyatomic ion because we have sulfur and oxygen jammed together in what is definitely going to be an anion. So we have name the cation, name the anion. Well, what is that anion? If it has multiple elements associated with it, it is a polyatomic ion. We check the polyatomic ion sheet and we see that we have sulfate. right? Sodium ions and sulfate ions. We have two of those, which is why they cancel out to make a neutral compound of sodium sulfate. But you just need to name it. Name the cation, name the anion. You're done. You're done. It's easy. Come on now. It's easy. Except for this part. This is where things get a little tricky. FeCl2. What are we dealing with here? Well, we know what Fe is. We look in the periodic table. We see that it is iron. But there's a trick to this. Iron is a transition metal, and most of the elements on the periodic table follow this rule. We need a Roman numeral, just like we did in the previous video, to identify the charge on our iron ion. Because iron could have multiple oxidation states, and depending on what that charge is, it could drastically alter what the formula is going to be. So how do we figure this out? Well, we know the element's name, it's iron. We leave space for the Roman numeral. Cool. The last thing we need to worry about is the anion, and that's actually going to be the key to helping us figure out what the charge on the metal is. Cl, we have two of them, okay? It's just one element by itself, Cl. So it's going to come from the periodic table. That looks like chlorine, and if its name was changed to be a monatomic ion, I'd change chlorine to chloride. Okay, so there's our anion, chloride. We have two of them though. So let's do this. The way you can figure this out is kind of like reverse engineering the charges of the ions by looking at the formula. Instead of crossing down your charges to find the formula, we're going to use the subscripts in the formula and cross them up to find the charges. So here we go. I'm going to write the symbols of my ions. Iron with a positive question mark charge. We don't know what it is. Chloride with a -1 charge, because it comes from group 7 on the periodic table. It's going to take on that -1 oxidation state when it becomes stable. It's just one ion at this point. Then I write my formula beneath it. Okay, we have 2 chlorides in this formula, and I'm actually going to write the 1 in here. It helps me to show the transition between the charges up here and the quantities in the formula, even though we don't write 1s in our chemical formulas when we finalize them. What I'm doing now is I'm going to cross this number back up instead of crossing it down. And why I'm doing this, I'm trying to check and see if any simplification occurred when the numbers were crossed down. If simplification did happen, those numbers wouldn't be the same, right? So by virtue of the fact that this one maps out and corresponds to this one, well, no simplification happened. So I can effectively multiply by 1 to undo this process and check the charge on my iron ion. 2 times 1 gives me the charge on my iron ion, which is going to be iron 2 chloride. Okay? That's as bad as it gets, going from a formula to a name that contains an element in the transition metal category, or any element that is not part of group 1, group 2, or silver, zinc, or aluminum, or ammonium. But that's a polyatomic ion. Give the rest of these a shot, check the answer key, and if you need help, please let me know. Those are the 4 different types of nomenclature that you are going to see in this test and in this course. Again, that's binary ionics, binary covalent molecules, ionic compounds that contain polyatomic ions, and ionic compounds that contain an element that requires a Roman numeral, which may be a transition metal or a post-transition metal. You get the picture. Again, questions, please let me know, and I hope you enjoyed the video. Thanks.